AWS Transit Gateway Overview. AWS Transit Gateway is a managed service that helps you connect your Amazon VPC AWS accounts, and on-premises networks through a central hub. As you expand globally, inter-region peering connects transit gateways together using the AWS Global Network. Your data is automatically encrypted and never travels over the public internet. Because of its central position, AWS Transit Gateway Network Manager has a unique view over your entire network, even connecting to software-defined wide area network, or SD-WAN devices. Here are some key benefits. Centralized network management. Transit Gateway simplifies network management by providing a single entry point for all connected resources, eliminating the need to manage multiple VPCs and on-premises networks separately. High scalability. Transit Gateway can handle millions of routes and support up to 5,000 VPCs and on-premises networks per Transit Gateway, making it ideal for customers with large and complex network environments. Cost-effective. Customers pay only for the resources they use, making it a cost-effective solution for networking needs. It also removes the need to purchase and manage expensive hardware, such as routers and switches, saving customers money on upfront costs and maintenance. Here are some key features. Security. AWS Transit Gateway integrates with Identity and Access Management, IAM, and enables you to manage access to AWS Transit Gateway securely. Using IAM, you can create and manage AWS users and groups, and use permissions to deny and allow their access to the AWS Transit Gateway. Routing. AWS Transit Gateway supports dynamic and static Layer 3 routing between Amazon VPCs and a VPN. Routes determine the next hop, depending on the destination IP address of the packet, and can point to an Amazon VPC or to a VPN connection. SD-WAN compatibility. Compatible SD-WAN partners of AWS, such as Cisco, Aruba, Silver Peak, Aviatrix, and Versa have pre-configured AWS site-to-site VPNs so that SD-WAN solutions can automate the connection of your remote sites with AWS. With AWS Transit Gateway Network Manager, you get a unified view of your network across AWS and on-premises networks. Amazon Virtual Private Cloud, VPC, peering connections. A VPC peering connection is a networking connection between two VPCs. This connection enables you to route traffic between your VPCs using private IPv4 addresses or private IPv6 addresses. In this way, instances in either VPC can communicate with each other, as if they were on the same network. When creating peering connections, you aren't just limited to your own VPCs in your account, you can peer with VPCs located in different AWS accounts. Moreover, the VPCs can be in different regions, also known as an inter-region VPC peering connection. With this in mind, VPC peering provides a simple and cost-effective way to share resources between regions or accounts. Additionally, VPC peering connections help facilitate the transfer of data. This can be used in a variety of scenarios such as replication of data for data redundancy, or to promote communication within organizations with uses like a file-sharing network. When creating peering connections, AWS uses the existing infrastructure of a VPC. It is neither a gateway nor a VPN connection, and does not rely on a separate piece of physical hardware. As a result, peering connections prevent problems such as a single point of failure for communication, or bandwidth bottlenecks. Peering connections also use the AWS backbone. Since traffic always stays on the global AWS backbone, and never traverses the public internet, VPC peering effectively reduces threats, such as common exploits, and DDoS attacks. Next we will examine how to establish a VPC peering connection between two VPCs. The first VPC will be our requester, and the second will be our acceptor. To establish a VPC peering connection, you do the following. First, the owner of the requester VPC sends a request to the owner of the acceptor VPC to create the VPC peering connection. Before we continue with the steps, it's important to note that VPC peering doesn't support all configurations. For example, the acceptor VPC cannot have a CIDR block that overlaps with the requester VPC CIDR block. For the second step, the owner of the acceptor VPC, which is either you or another AWS account, accepts the VPC peering connection request to activate the VPC peering connection. The VPCs are now peered. Next, to enable the flow of traffic between the VPCs, the owner of each VPC in the peering connection must manually add a route to their desired VPC route tables. That route must point to the IP address range of the other peer VPC. Finally, if required, update the security group rules that are associated with your instance to ensure that traffic to and from the peer VPC is not restricted. Now that your VPCs are peered, you can go ahead and peer it with multiple other VPCs. However, note that VPC peering connections do not support transitive properties. All peered VPCs must be directly peered with each other. Similarly, VPC peering connections cannot use edge-to-edge routing to access resources it does not have direct access to, such as an S3 bucket.
Amazon Virtual Private Cloud. VPC Overview. Amazon Virtual Private Cloud. Amazon VPC is like your own private cloud within the AWS cloud. It lets you provision a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network that you define. This is a virtual network dedicated to your AWS account. Alternatively, your AWS account comes with a pre-configured default VPC in each region. You can launch your resources into the default VPC right away. Amazon VPC also provides you with complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. To get started with creating a VPC, you must assign it with a range of private IP addresses. Amazon VPC supports IPv4 and IPv6. Your resources can communicate over IPv4 or IPv6 or both. By default, it uses the IPv4 addressing protocol. You can also bring your own IP prefixes. A VPC spans all of the availability zones in the region. After creating a VPC, you can add one or more subnets in each availability zone. A subnet is a partition of a VPC's IP address range. For example, your VPC has a total of 1024 IP addresses, and you configure 4 subnets, each has 251 IP addresses. Each subnet must reside entirely within one availability zone. You can launch instances into subnets in multiple availability zones to improve fault tolerance and hence, building highly available applications. Creating multiple VPCs is supported. In one AWS account, you can create up to 5 VPCs per region by default. If more is required, this limit can be increased through AWS support. Now, let's talk about the key benefits of Amazon VPC. First, it is simple. Using the AWS Management Console, VPC can be quickly and easily created. You spend less time setting up and managing, so you can concentrate on building the applications that run in your VPCs. Customizable. You can easily customize the network configuration of your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet. You can also place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. When you configure VPC to connect to your corporate network, it can serve as an extension of your own data center. In addition, VPC can also be connected to other VPCs. Secure. Amazon VPC provides multiple layers of advanced security features, such as network access control lists, NACLs, and security groups, to enable inbound and outbound filtering at the subnet and instance level. In addition, you can store data in Amazon S3 and restrict access, so that it's only accessible from instances inside your VPC. Amazon Virtual Private